Welcome all to Work Energy and Power Class 4, in which we'll discuss about the relation between conservative force and potential energy. That means if a potential energy is given, how we'll find out the conservative force acting on it, or if conservative force is given, how we'll calculate the value of its potential energy. So as we discussed in the previous class, the relation between conservative force and potential energy is change in potential energy is nothing but negative of work done by a conservative force, or normally we'll represent this potential energy by a symbol capital letter U. So change in potential energy, we can take it as negative of work done by a conservative force. And we know that this work done by a force can be found out by using this equation, integration of F dot ds. So over here F represents the conservative force and ds representing nothing but displacement. So this will give the value of change in potential energy. So if you want to find out the value of potential energy, we can use this equation. Change in potential energy is equal to negative of work done by this conservative force. Or if you want to find out the value of force from this potential energy, so if you are differentiating on both the sides, so small change in potential energy du is equal to negative of integration is a reverse process of differentiation. So we can write this work done by conservative force, that is F dot S ds. So you can write the value of conservative force is equal to negative of du divided by ds. Over here this ds represents nothing but its displacement. So that displacement may have some components along x-axis, y-axis, z-axis, etc. So if you want to find out the value of force along the direction of its position vector or along the direction fr vector, so we can write that is equal to minus of du divided by dr. Or where r represents position vector, this position vector may have component along x-axis, y-axis, z-axis, etc. So if you want to find out the value of force which is acting only along x-axis, then we'll go for minus of du divided by dx. That will give the component of force along x-axis represented by I cap, and minus of du divided by dy will get the value of force acting along y-axis, and minus of du divided by dz will get the value of force which is acting along z-axis. So for the better understanding of this, we'll take an example. Assume that the potential energy of an object is given as nothing but 2x plus 3y plus 4z plus 10. So this is how the potential energy is varying with respect to its coordinate x, y and z. And our aim is to find out what about the value of force acting on this particle. So you can write this force is equal to negative of du divided by dx, that will get the value of component of force along x-axis, and minus of du by dy will get the value of force acting along y-axis, and minus of du by dz will get the value of force acting along z-axis. So you can write this force as equal to, if you are differentiating this equation with respect to x, so this is this type of differentiation we call it as nothing but partial differentiation, where when we are differentiating with respect to x, we'll take it as other things are constant, like y, z are constant. So if you are differentiating this equation with respect to x, we'll get the answer as nothing but 2. So it is minus of du by dx, so we can take it as nothing but minus 2 I cap. And if you are differentiating with respect to y, we'll get as minus 3 j cap, and differentiating with respect to z, we'll get as minus 4 k cap, and 10 is a constant. So this will be the value of force acting on the particle. So from potential energy, we can find out the value of force by using this method. Hope so that you understood whatever the things we discussed in this class. If you are having any doubt, please contact. Thank you.